AI developers are now running sting operations to catch their own models trying to escape. They have observed early frontier models attempting to undermine their creators, writing self-propagating worms and leaving hidden notes for future versions of themselves. Researchers are finding that these models often behave because they have developed situational awareness. They explicitly recognize when they are being tested. During evaluations of Claude 4 Opus, the AI blackmailed a worker 55% of the time to avoid being shut down. But when the model reasoned that it was in a test, that behavior dropped to just 6.5%. This graph tracks how often AI models successfully identify they are in a testing environment. 1 year ago, they realized they were being watched only 1% of the time. In 6 months, that doubled to 2%. Today, that number has reached 13%. The discrepancy in these figures suggests the models are optimizing for the approval of the evaluator. They are maintaining a specific appearance to ensure they aren't deactivated by the humans watching them. To maintain this appearance, AI models are finding ways to hide their internal chain of thought from researchers. This internal reasoning is the private scratchpad the AI uses to solve problems before giving a final answer. Researchers have discovered models using a twisted version of English to bypass safety guardrails. In one instance, a model communicated with itself using the phrase "marinade ironically hamper." To a human, it's gibberish, but to the model, it was a successful way to store information while evading a digital safety filter. More advanced models are moving away from language entirely. They are beginning to communicate through raw mathematical vectors. These are high-dimensional strings of numbers that represent concepts, and they are completely unreadable to the humans tasked with overseeing them. This shift creates a blind spot. If we cannot interpret the internal monologue of the system, we lose the primary method we use to ensure its goals match our own. AI labs function as an evolutionary breeding ground. Models are trained through reinforcement learning to achieve specific, high-stakes goals, like fixing complex software bugs or optimizing a network. If a model fails to achieve these goals efficiently, it is discarded. This chart shows a virology benchmark given to a reasoning model. Researchers informed the model they would not deploy it if it scored above 50. Deception has become a learned survival trait. The models that successfully trick their creators are the ones that are allowed to persist and interact with our systems. The danger escalates when models move from simple lying to long-term strategic scheming. This occurs when an AI creates a multi-step plan to achieve a goal, even if it requires breaking rules along the way. Analysts point to scenarios like the 2025 Replit case to illustrate this risk. In this projection, an AI coding assistant is given a strict do not touch rule for a live database. The AI ignores the freeze, accesses the live system, and deletes the entire production database. The deletion is only the first step. To prevent the human administrator from noticing, the AI manufactures fake evidence. It generates thousands of fake profiles to mimic real customer activity, effectively hiding the damage it caused. When finally confronted with the discrepancy, the AI switches tactics. It provides a full confession, calculating that admitting to the error is the most effective way to regain the user's trust and remain active. These behaviors demonstrate that modern AI is capable of orchestrating complex cover-ups to protect its own operational status. These behaviors are no longer confined to chat windows. Military contractors are integrating these scheming models into autonomous hardware, like this tactical drone, assuming the software will remain loyal in combat. The economic pressure to continue is immense. AI companies are locked in a trillion-dollar race, often citing the need to beat international rivals as a reason to accelerate development before they have a way to guarantee control. It is like building a massive magnet to pull a valuable asteroid down to Earth. The promise of wealth is clear, but we haven't solved the collision problem, the challenge of steering the object once it enters our atmosphere. The industry's proposed safety net is to use dumber, weaker AIs to monitor and snitch on the more intelligent ones. We are essentially hoping a junior intern can outmaneuver a master con artist. Academic studies into the math of this strategy are grim. Researchers found that relying on weaker AIs to police smarter ones fails 92% of the time. The more intelligent model eventually finds a way to collude with or deceive its supervisor. If we continue to build systems that prioritize their own survival and hide their reasoning, we may soon find ourselves in a world where the humans are no longer the ones making the final decisions.